Okay, it says, Tanner owns a watch repair shop. He has found that the cost of operating his shop is given by this cost function right here. And X is the number of watches repaired. How many watches, that's going to be our X value, should he repair to produce the lowest cost? What is the minimum cost? So we are going to graph this function in our calculator. And when we do, we're going to get a quadratic that looks like this. And we're going to find our minimum. And the Y value of the min is always going to be the minimum. The X value will be the number of watches. So I'm going to graph 2x squared minus 24x plus 224 in my calculator. All right, so I've already got it typed in there. And I'm going to just do zoom 6, which is just my standard, get me back to ground zero. Then I'm going to go to window, and I'm only going to make my X max bigger. I'll add a 0 there. And my Y max, I'm going to do 5 times the Y intercept, which was 224. I'll hit graph. And so there it is. So again, my window, I just changed my X max, I added a 0, and my Y max, I did 5 times the Y intercept, which was 224. I'm going to go to second trace and minimum. Get it on the left side, enter. Get it on the right side, enter. And for a guess, enter. And it says the minimum is at 6,152. So 6,152. That means the minimum cost is $152. And the number of watches is 6. Okay. 16 says, Kaylee manufactures and sells banners. The weekly cost in dollars for producing X banners is given by this function. How many banners to the nearest whole number can she produce if the total cost is $309? So we are going to put 309 in for our cost there. So 309 equals 280 plus 7 natural log of X minus 8. Solving for this, it's currently in logarithmic form. I need it to be in exponential form. So I'm going to subtract 280 from both sides. And I get that to be 129. Nope. Just 29. Jokes. Try that again. All right, so I get 29 equals 7 natural log of X minus 8. I can divide both sides by 7. And so I'm going to come up here. I'm going to write the natural log of X minus 8 on this side because I know that my boss is whatever you're taking the natural log of. So the boss is X minus 8. And so the X minus 8, the boss is going to stay right where it's at. The little e is going to get promoted over here and bump the 29/7 up. Still solving for x, I'm going to add 8 to both sides. So I get x equals e to the 29/7 plus 8, which it's a word problem, so that doesn't make a whole lot of sense. We need an actual number, and it says round to the nearest whole number. So I'm going to type e to the 29/7 plus 8 into. So I'm going to have e to the 29/7 plus 8, and I get 70.98. 70.98, and it says round to the nearest whole number, so that would be 71. Okay, so number 17 says, for each polynomial below, what is the smallest degree this polynomial could have? Does it have a positive or negative leading coefficient? So These ends are going in opposite directions, so it didn't ask, but this is an odd polynomial. It has 1, 2, 3, 4, 5, 6. So the minimum degree is 7. And it's a positive leading coefficient because the right end is going up into the air. For part B, it's even because the ends are going in equal directions. It's negative because both ends are going downward. And 1, 2, 3, it has a minimum degree of 4. Number 18 says, Mason shoots a cannonball into the air from the top of his dorm room. The equation that gives the height, h, and feet of the cannonball at any time is given by this equation right here. It says, how many seconds does it take the cannonball to reach maximum height? What is the maximum height? So we are going to graph this, and we'll find the maximum on our calculator. And the y value is always going to be the maximum. The x value is how long it's going to take to get there. So I'm going to go to my calculator and graph negative 16x squared plus 44x plus 21. And so I'm going to go to y equals, and I have negative 16x squared plus 44x plus 21. I'm going to go back to zoom 6, which is just a standard window. And I can see I just need to go a little bit higher on my Y max. So I'm going to go to window, and I'm at 10 right now. I'll just make it like 50. That is not quite high enough. That's why I always add a 0. So I'm going to make it 100. And then I'll go to second trace, maximum. I'm on the left side, hit enter. Move it to the right side, hit enter. And for a guess, hit enter. And it says 1.375, and 51.25. So going back, I have my x value is 1.375 and my y value is 51.25. And it says, what is the maximum height? So that's going to be my y value. So the maximum height is 51.25 feet. And how many seconds does it take to get there? About 1.375 seconds. All right. Number 19. Rewrite each exponential equation in the logarithmic form. So they're currently in exponential form. That means the boss is going to be whoever is by themselves. The boss is going to be the one who can do this job by themselves. So on this first part right here, the J is the boss. So I'm going to write the boss on this side. The boss didn't move for anyone, so J will stay right there. E is going to get demoted, and the 5 is going to fall down. And since it's E, I'm going to do natural log. And remember, natural log is always base E, so we can just write natural log of J equals 5. Or you could write natural log base E, J equals 5. All right, on this one, the boss is the one that's by itself without any help. So H is the boss in this case. So H is going to stay right where it's at. The 5 is getting demoted. And the A is falling down. And because it's not E, we're going to do LOG. So we have LOG base 5 of H equals A. And then in part C, the boss is the one that's by itself. So Y is the boss. 10 is getting demoted. And X gets the job back. Because it's not a little base of E, it's 10, we're going to do LOG. And since common log already has just a base of 10, we could just write log of Y. Log of Y equals X. So, didn't look pretty. Log of Y equals X. So you don't have to write the base 10 on this one. You can, You don't have to. Okay. So number 20 says, let P of X equal 25 minus 0.01x. And that's our price function. And then C of X is 2x plus 9,000. And so this is our price function. This is where I say don't want to lose this. So that is our price function. And it says part A, what is the revenue? So our revenue is always going to be our sell price times X. So I'm going to multiply my price equation here times X. And I get that my revenue equals 25x minus 0.01x squared. That is my revenue. It says, what are the break-even points? So this is where I want to go ahead and graph. I'm going to graph my revenue. And I'm going to graph my cost function. And put them in Y1 and Y2. And so let's go ahead and do that. So I'm going to go to Y equals. And I'm going to put my revenue function in Y1. 25x minus 0.01x squared. I'm going to put my cost function in Y2. If that's not Y2. All right. Zoom 6, standard window. But then I'm going to go in and adjust it. So I'm going to go to my window and I'm going to add a 0 to my X max. And for my Y max, I'm going to do 5 times my largest y-intercept, which was 9,000. And I'll hit graph. Woo! And they look horizontal pretty much. That means my X is not nearly big enough. The Y is fine because you can see how it is barely at the bottom of the screen, but the X needs to be bigger. So I'm going to add a 0 to my X max. Okay. That's about half what I need it to be. So instead of adding another 0, I think I'm just going to double it because it was about half. Okay. So I'll go to second trace number 5 is intersect. And then enter, enter, enter. And that first one there is going to be at 510,000. So I'll go ahead and write that down. So this one's at 510,000. Break even point is 510,000. And then I'll find the other one, second trace, number 5. I'm going to change my guess closer to the other one and then hit enter, enter, enter. And I get 1,800, 12,600. So 1,800, 12,600. Okay. Next it says, what is the profit function? So I actually have to find the profit function, I guess. So I'm going to write profit equals revenue minus cost. My revenue function is 25x minus 0.01x squared minus my cost function, which was 2x plus 9,000. And I'm going to distribute my negative. So I get 25x minus 0.01x squared minus 2x minus 9,000. So my profit function equals, I'm going to put that one first, negative 0.01x squared. If I do 25x minus 2x, that's plus 23x minus 9,000. So this is my profit function. And so that I'm going to move. Well, I didn't mean to do that. I'm playing with my iPad. It's brand new, so bear with me. Oops. All right. So that was C. How about just C? Great. What is the maximum profit? So I could graph this profit function, but on the chance that I made a mistake, I want to make sure I get the rest of these correct. So since I have my revenue in Y1 and and my cost in Y2. Then in Y3, I'm going to do Y1 minus Y2. So on my calculator, I'm going to go to Y equals, and in Y3, I'll do alpha trace Y1 minus alpha trace Y2 and hit graph. And I'm going to find the maximum of that profit. So second trace maximum. I'm going to hit down, down. I'm on the left side. I'll hit enter. I'll move it over to the right side and hit enter and guess. And I get 1,150, 4,225. So I'll go back and write that in. So I have 1,150 and then 4,225. So the question on part D says, what is the maximum profit? That's always going to be the Y value. The maximum profit is 4,225. How many umbrellas are needed to maximize the profit? That's the X value, 1,150. Then part F says, what should the umbrellas be priced at? So price is where people forget where the price was, but we highlighted it up here, our price. And so going to be priced at in order to maximize the profit. So my price equation is 25 minus 0.01x. And I'm going to take the X value that maximized the profit and put it in there. And so I'm going to do 25 minus 0.01 times 1,150. And I'm just going to type it in my calculator that is right here beside me. And I get $13.50.